Be a good continuation of what we have done in the morning. Here's what I have. The first thing, since we're doing dwelling, so let's focus. I'm using an NMB as a wiring method. Can you guys emphasize this one? So important, because I'm using an NMB as a wiring method, which forces you to use which column? 60-degree column. If I use a different wiring methods, you can go to 75-degree column. Okay, here's what we have. We have a 240/120 single phase panel. I don't care what the amp is, but 300 amp, and I have two electric furnaces fed from this panel. I could have, and of course there will be other things. And these two electric furnaces, they're both the full load amp 79 for the first one, 240 for the second one. Full load amp is 53, voltage is 240. It's furnace A, furnace B. I need to size the conductor that feeds the furnace, the overcome protection device that protects it, the disconnect that disconnects it, as well as the equipment grounding conductor that goes with these boys. Everybody understand what we're trying to achieve? This is our probably 56, maybe 8 things that we have done the same way. Guys, with Chad and with us as a designers, when we teach sizing, we don't do calculation for the sake of calculation. When we do calculation because we're going to throw a blueprint size, that's what I draw all this stuff for you, so you know why do you use it. So if that was in your plans, that's how we size it. You put it in the plan, the electricians will go size exactly based on what you did. So, okay. Everybody understand what we have? These are electric furnaces, and we are to size the disconnect, the overcome protection device, the grounding conductor, as well as the ungrounding conductors. Shall we go ahead and start? Okay, for both of them. I remind you we're using an NM cable. So the first thing I would like guys to size is size the branch circuits. For branch circuits, before we go ahead, for furnaces, electric furnaces, guys, we have any electric furnaces, we have appliances. The article that you're going to be dealing with is article 422. These are appliances 422 as well as 424. These are the articles that we're going to be pulling information from. The articles that we're going to be pulling information from. Okay, for branch circuits, it's a continuous load, so what you need to do, 1.25 multiply, I'm doing the calculation for A, furnace A. We'll do it for furnace B in a second. Times 79 amps, and if you do the math right, that will get you 98.8 amps. 98.8 amps, and your NEC reference for this one is 422.108. That's your NEC reference for this, being an appliance. And then the next step, guys, is piece of cake. You take the 98.8 amps, you're going to take it to table 310.15 B16 under 60-degree column. Why? Because we are using an NM cable, and your also reference for this one is article 334.80. That's for an NM cable. If you apply all these references, you're going to end up with 2 conductors. Since we're using this NM cable, I'm going to use number. I hope they make it 1-2. 1, 2 is size 1, 2 conductors, AWG, and it's the wiring methods that we're deciding to use. It's called the NMB cable. NMB cable. Hopefully they'll make it. Number 1, 2. So it's what's not 1? The size is 1. How many conductors? 2. Done. Your reference for this one, for the sizes, they want the reference for it. Okay, so the reference is also 424.3B. It's always good to write references, guys. For branch circuits, 422.10A for appliances, 424.3B, that's for heating elements. They both of them, Derek, they both tells you it's continuous load multiplied by 1.25. That's all. The 334.80, it will tell you for NM cable, don't you dare using more than 60-degree column. Math, especially math, because you came from first semester. Does it make sense when I write this, guys? You go to this table, you go under this column, right? Is it making sense to everybody? When I write the table at the top, the column right next to it. Very important. It's not enough to say go to the table, guys. You go to the table, which column am I going to be using, right? There's 3 columns. Pick one, right? No, you can't pick one. You're going to use specifically, strictly go to this one. Okay, overcome protection device. Am I going too fast? Too slow? No. Overcome protection device. Now moving to the overcome protection device. Your section, guys, for the overcome protection device, your 422 and 424.3b. 424.3b for resistive heat. It will tell you the following. It will tell you the following. Take 101.25, like I told you guys, times 79. Same calculation that we've done in a second. 78.8 amps. Same calculation, no magic. Then you take the 78.8 amps. Make sure you take it to 240.6. That's where you find the standard non-adjustable circuit breakers. And that will get
98.8. I was gonna say.
Well, I must have to multiply a number by increase it 25% and come up with a lower number. You invented new math. That's right. Thank you. 98.8 amps. 98.8 amps. That's why I told you guys keep me awake. 98.8 amps. Right? 98.8 amps. And then this will get you 100 amp circuit breaker. 100 amp circuit breaker. So your system will look something like this. Here's what your system is going to look like. I have 79 amp furnace, and my conductor here will be number 1, 2, an amp cable, and my overcome protection device is going to be 100 amp 2-pole circuit breaker, and this will be an MB cable. That's it. Now you go. Great. Now that's sized. I want to remind you, now we need to go put a disconnect right here. We need to put a disconnect right here, right? And we also need to pull the equipment grounding conductor. Don't forget that there's an equipment grounding conductor. Next. Right? I'm just redraw what I drew in the beginning. No, nothing new. Shall we move? Are you guys fast? Why are you so fast? So last time you were slow because I didn't give you that graphic. You got stuck doing it. Okay, disconnect. For your disconnect, let's go for my disconnect. For my disconnect, guys, I use the same calculation, 1.25 multiplied by 79 equal 98.8 amps, okay? And then from here, 98.8 amps, take it to D watt, page 312, 3-12. Why do I go to D watt? Because disconnects are not in any secret book, the disconnect sizes. And that will get you 100 amp, 2-pole, 100 amp, 2-pole disconnect. 100 amp, 2-pole, 2-pole disconnect. You're looking at it right here. It will get you something like this. 100 amp. Disconnect. Why do we have a disconnect? Because we're sick of killing people from electricity, burning them, and losing their fingers too. Safety. Main reason for it is safety. Equipment grounding conductor, very easy. You take the 100 amp fuse, it's always based on the fuse, guys. And you go to table 250.122. And when you go there, it's only one column there. And by the way, there are two, but copper and aluminum. Unless I tell you aluminum, it's always what? Copper. So you go to the copper, and in the copper department, you can have a number 8 AWG in your NMB cable. I will remind you guys, we're pulling cables here. So that will be, you really will be sized inside your cable. That's it. Now let's go repeat ourselves one more time for the second furnace. Everything that we have done, we're going to repeat it for the second furnace. Do you see that? Hopefully, we keep hitting it with stick, guys. Any comments, any questions, guys, about these? All right, let's go to the second furnace. Done? Good? Okay. Second furnace. I have my second furnace, guys. Let's go size the same process. You guys can go right before me even. Same process for the second furnace. The second furnace, guys, 1.25. You can times it by 53. 53 amp, because that's the amps for this boy. 66.3 amps. Then you take your 66.3 amps, take it to table 310.15 B16 under 60-degree column. We know why, right? That will get you number 4-2 AWG, and this NMD cable. By the way, what's the insulation in the NMB cable? NMB cable, the insulation inside it is THHM. So it has a THHM insulation. So they're individually wrapped with a cover. That's why it's called a cable. All three of them, all of them are wrapped with a cover. That's where the cable comes. And they're individually wrapped with an insulation that's called THHM. Am I making sense, guys, when I say a cable? Here's the three conductors that you have, 2 hots and 1 ground. So these two guys will be wrapped with insulation called THHN. Typically, the ground will be bare. You put them together and you cable them with a cover over them. But they are individually, they are THHN conductors. So theoretically, you can pull them out of a cable and pull them into a conduit. It will be an expensive way of doing business. Taking an NM cable, taking the conductors out of it, and putting in an EMT conduit. It's okay, it's a THHN conductor. Still a good idea though. Okay. Second, let's go to the overcaptation device, same size, 1.25 multiplied by 53, get you 66.3 amps. Now where are you going to go? 66.3 amps, take it all the way to 240.6. That will get you a healthy 70 amp, 2-pole circuit breaker. 70 amp 2-pole circuit breaker, done. By the way, could I have gotten a 50 amp circuit breaker or 60 amp circuit breaker? 60 to make 60, 50 amp circuit breaker? Yes. But you will be under, your equipment might not work. It doesn't work. We'll trip the circuit breaker. The next standard, not the standard after. Should we go to the third?
So if there's a question like this on a test, then we don't have to do all, but
well, you don't need it. This one is 240.6. This is from NEC code book. But what you're referring to the disconnect, you stop right here. 98.8. If you tell me, Chad, what's the next stand, I can kill you. It's 100. But I want you guys to have this material by the commercial project. But I mean, it's not a big deal. You stop at 98.8. That's all. And tell me what's the next stand, or I can use mine. It's really not hard. I'll show you. But eventually, I want you to have that one, will you? Okay. So let's go to what's next. Disconnect. For my disconnect, my friend, same calculation. 1.25, multiply this one by my 53, gets you 66.3 amps, and 66.3 amps, take it to P12, 3-12, will get you back to 100 amp. 100 amp, 2-pole, this connect. 100 amp 2-pole disconnect. Whitman grounding conductor, guys. Piece of cake. You take the 70 amp because the circuit breaker 70 amp. Take this one to 250.122 cable, and that'll get you one conductor number 8, A, AWG in an MB cable. Any question, guys, about these? So these are two examples for furnaces. I have two more examples for baseboard heaters, and then two more examples for AC units, but I'm not going to do the AC today. I'll leave the AC for tomorrow. Is that okay with you guys? We'll just do two more examples for baseboard, and the AC units I'll do them tomorrow. Because I need your full undivided attention for the AC. Comments, questions? Okay, so we size all this. Now let's go back to the question number 2. Baseboard heaters. What's the difference between furnace and baseboard heaters? Furnaces, guys, they have a blower with them, right? You have you heat and you blow the furnaces. Baseboard heaters typically don't have a blower. They don't have a fan, do they? They don't have a fan. That's all. But the way we size them the same though, continuous load. Okay, here you go. Same thing. NMB is the wiring methods. 424 is the article that talks about baseboard heaters. I have the same panel for 24120. By the way, Derek, when you put a panel, if you don't put the amps of the main panel and the voltage and what phase and what frequency, you have no clue what we're talking. It's like, what do you drive? I drive a car. Hey, what type of a car, right? So that when you say a panel, doesn't mean much. When you say in the electrical design industry, a panel has to have a voltage, has to have an amp, has to have a frequency, and has to have a phase. Is it single phase or 3-phase? Now we're talking. Does that make sense, guys? It's not enough because this panel could be 480, 277, 208, 120, 240, 50 hertz, could be 3-phase, could be single phase, could be 2-phase even. So very, very important, guys, to get into the habit of identifying what you want. Ultimately, you're sending this to the electricians, and the electrical contractor is not going to sit there and guess you what do you want. I'm not going to second guess you. You will give them enough information. Okay, baseboard heaters. 2 of them. Why 2? Just because the exercise. It could be 5, 10, 20 of them, as a matter of fact. And I need to size, same thing. I need to size the number 2, lower competition device, the conductor, disconnect, and all this stuff. For baseboard heaters, guys, the disconnect could be the switch on the baseboard heater, the thermostat, that acts as a disconnect. So you don't have to have a big blown disconnect for the AC units. Look at the sizes. They are 240, 2.5 kW, 120, 1.7 kW. These are typically the sizes that we use in dwellings. We don't use 10 kW, smaller sizes. Shall we go ahead and start sizing? Everybody knows what we have before we start? Karen, good? Okay, now let's go ahead and start sizing the following. Remember, they are Article 424. They are continuous load, so we are to size them as follows. The first thing you need to do, guys, is find the amps, because we size conductors and everything else based on the amps. 2.5K divided by 240. That will get you a healthy 10.4 amps. 10.4 amps, right? Then you take the 1.25 and multiply this baby by 10.4. Why 1.25 amp? Continuous load, 240, 424 tells you if it's continuous load, add 25% extra when you size your conductor. That will give me 13 amps. 13 amps, okay? Then you take your 13 amps and take this one to table 310.15 B16 on the 60th degree column, and that will get you number 14.2 AWG and MB cable with insulation THHN. The insulation in the cable is THHN. Done. So for this, that's all what I need. That's all I need. Overcome protection device, the circuit breaker is piece of cake. Same calculation, 1.25. Multiply this baby by 10.4. It will get 13 amps. You take the 13 amps to 240.6. That will get you a 15 amp circuit breaker. Two pole circuit breaker. 15 amp 2-pole circuit breaker. Everybody understand what the difference between 2-pole and single pole? The difference is two things. Price is difference, and number two, one of them has two hots, the other one has one hot. A pole is a hot, right? Not a neutral. When you say single pole, you're talking about a hot for the most part. Any comments, guys? Any questions? Over current is supposed to be a current here. Protection device, circuit breaker. See how easy that is? Piece of cake. Can I move on? Yes, no? Okay. Next, disconnect. For my disconnect, guys, I can use, are we here? Okay, disconnect, I have for disconnect, I'm going to use 1.25 multiplied by 10.4. I came up with 13 amps, Okay. $13 amps. Okay, now, here's what you do with the 13 amps though. 13 amps, here's what you can size. You have a couple of options. Option number one, guys, is to go to DeWalt 3-12. That will get you a 30 amp 2-pole disconnect. Option number two, there's a bunch of options here. And I'm going to pick the right one. Punch, done. Now that would be a big one. That's a huge for our application. Option number two, guys. Option number two, you can have thermostat 13. You can have 15 amp thermostat with, okay, let's use your thermostat that's controlling it. Thermostat with off position. That's option two. So a 15 amp thermostat that controls it has an off position that acts as your disconnect. So 15 amp, 13 amp, okay, 2-pole. So option number two, you can have, another option is you can also have a 15 amp, 2-pole snap switch. That's another option. Why? Because the amps are small. On smaller equipment and baseboard heaters. So let me tell you what the most common option you're going to find. And I want you to highlight. The most common option will be this. The thermostat itself. Can you guys write? My thermostat that has an off position, inline thermostat will act as your disconnect. Right? When you put them in, your thermostat has an off position. That's your disconnect for the equipment. Can you guys highlight that one? The 15 amp? That's what we typically do with these. Any one of them will do a disconnect for them though. The last thing is equipment grounding conductor. For equipment grounding conductor, guys, you take the 15 amp, take it to 240. You take it to table 250.1, 2, and 2. If you want conductor, number 14, AWG in NMB cable. And typically this will be bare. In an NM bare, no insulation. Typically. Could it be insulated? Bring it on. No problem. Any question, guys, about this? Shall we hit the last one? Shall we? Okay, the last one. The last one, my friends. There you go. I have B. I have, where am I here? B. Okay. For B, I need to size the branch circuit. The first thing you need to do is find the current. Current equal 1.7K divided by 120 volt. Matt, why do you think I divided by 120 here, not 240?
Switched on that one.
This equipment is burning at 120, right? That's what you use, what the equipment is rated for. So if you can go right back to our example, it looks like I'm burning this equipment at 120. This is at 240. So you use the rated voltage of the equipment. Good point. Okay, so then when you do that, you end up with 14.2 amps. Cool. Then continuous load, 1.25, multiply this baby by 14.2, get you a healthy 17.75 amps, okay? And then you take your 17.75, we should make it 17.8. Let's just do 17.8. 17.8 amps. I don't like to carry too many digits. 17.8 amps. Take this one to table 3, 10.15 B16 under 60-degree column or Celsius. And that would be conductor is going to be number 12-2 AWG and insulation THHN cable NMB cable. And I like to throw all this. So it's a cable, 12-2 cable, NM cable. The conductors are in an NM cable, they are THHN. If you don't believe Chad, you're going to go to the article that talks about NM cable. It tells you that they are insulated at 90 degrees Celsius, which is THHN. Overcome protection device. Shall we do the overcome protection device? Same thing. Overcurrent protection device. For the overcome protection device, guys, we'll do the same basically the same calculation. 1.25, multiply that baby by 14.2 amps, and that will get you 17.8 amps. And what do? You take the 17.8 amps, take it to 240.6, that will get you how many amps? 20 amps, single pole, 20 amps, single pole circuit breaker, not two pole. 20 amp single pole circuit breaker. 20 amp single pole circuit breakers. 20 amp single pole circuit breaker. Makes sense? Very easy, straightforward. Next test, guys, will be on that. Plus motors. Move on, yes, no? Okay. Let's go to the disconnect. The disconnect, I would use the 1.25, multiply it by the same thing. 14.2, give it 17.8 amps. When you come to here, 17.8 amps. You have a bunch of options. You will have a 20 amp thermostat with off position. That's my choice, not typically. And or the other option that we said, 220 amp single pole circuit, single pole. We're going to have single pole snap switch here, or circuit breaker would work too. Snap switch. Snap. wedge. And the last option is again the wall 3-12. You can go ahead and put 30 amp single pole if they make them disconnect. Which one did we say we're gonna typically what we use? 20 amp. And by the way, the other thing is if the panel is really trying to disconnect at that baseboard heater, the circuit breaker itself can be disconnected. So your circuit breaker can be your disconnect. Okay, last thing is the overcome protection device. Using the overcome protection device. See on the test, guys, for example, like this, you just say a thermostat with an off position. So what you have to tell me. Okay, so what was it? That 20 amp? You're gonna take a 20 amp, take it to table 250.122. That will get you one conductor number 12 AWG THHN NMB cable. That's it. Any comments, guys? Any questions? Any comments? Any questions? I do have a couple of two examples. I'll go over them tomorrow for the AC units because I want to focus a little bit on the AC units. I have you full undivided attention. Cool. Any comments? Any questions? So here's two examples. If you want to take examples, guys, to practice, just change these. I will be doing it in a commercial usually. Go change this number into 3 or 5, this number into 4, and do the calculation. That's what the test is going to be. Any comments? Any questions? Make sense? Okay. Thank you.